not A, or the complement of A, intersection B, intersection C, will be denoted on a Venn diagram in the following way. So let's break it down into parts. So let's look at this first, B intersection C. So B is simply that whole space, and C is that whole space. So the intersection of the two is going to be this area that is common to both. So we have B intersection C as this area. Okay, now what is not A? So basically, A is this. So not A, or the complement of A, is everything that is not what is blue here. So that'll be everything that I'm scribbling in now. So now we have to take the intersection of everything that's not A and B intersection C. So basically what we're doing is we're looking for what's similar in this and in all of this. So if you look carefully, in this diagram, there's really just two parts. There's this one here, and there's this part here. And if we look for these parts, those two parts in this diagram, we find that this little section is not shaded here, so there's no intersection. But this section that's shaded here is also shaded here. So our final denotation will be that. Let's move on to another example. So here we have B intersection A union with A intersection C. So first of all, we'll go and do B intersection A. So we know that B is all of this, and A is all of this. So the intersection is this space here. So that's done there. Now we do A intersection C. So we know A to be all of this, and C to be all of this. So the intersection is this space that lies in the middle. Now we've got to union both of these, so we're simply going to end up with this. A part that is both in here and in here. So we'll end up with something that looks like this. So we can scribble that in. This can be read as the complement of A union B union C. So A union B, we know to be everything that's in A or in B. So we'll shade in A and we'll shade in B. Okay, and B, and then C is just obviously everything that's in C. So A union B union C is everything that's in all three. So if we're doing the complement of that, it's everything that is not highlighted in green in this diagram. So it's all of this. So we'll fill that in over here. Now this may look tricky, but if you break it down, it can actually be quite simple. So we'll go ahead and try. So first of all, I noticed that there's a lot of components. There seems to be this big component here, this component here, and within this large component, there's three other components. So I'm going to go ahead and tackle this first because it's a lot simpler. So A intersection B is just everything that's in A and in B, which is just that area there. Now for this, we'll have to use a more complicated approach. So let's first tackle this part of it. And of course you can break things up in whatever way you see fit to make things as simple or as intuitive as you'd like. So I'd break that down first. So A union B, we know to be this. Everything that's in A or in B. Remember, a union can also be read as or, and an intersection can be read as and. So A or B, everything that's in A or B, and in C. So in C is this. So we've got to look for the intersection of the blue and the green. And that'll be this area here. So we'll go and fill that in. And we check that we're right. So we'll check that we're right with A union B is this area, intersected with C. So from these two bubbles, I'm going to intersect with the C, with this. So what's going to overlap is clearly this area, and it makes sense. And now we'll go ahead and tackle that component, which is not A intersection not B intersection not C. So we'll go ahead and like this, as so. So everything that's not an A is everything that's not that. Okay, so that's going to be all of this space. Everything that's not in B would be all of this. You can see I'm leaving out B, I'm leaving out A. And if I were to use another diagram over here, which I'll clean up before I write the final answer, we have C that's here. So not C is going to be all of this. So if we're looking for the intersection of all these three white areas, what we're essentially doing is leaving out the Venn diagram. So we'll clean this up, this one here, and we're leaving out this, this, and this, because the intersection gave us purely this. And as I'm doing these examples, I encourage you to please pause before I go through the solution and the understanding behind it so that you can get good practice yourself. So now we're looking at these three diagrams. And now first, I broke down this part of it into this and into this. And the thing that joins this, which was this, and this part, which was this part, is an intersection. So I'm looking for what's common between these two. And what you'll notice is that there's actually nothing in common. So those were essentially a waste of time. And if we union it, we're saying what's in all of this, which is nothing, the empty set, which is denoted as this, union with that. And this here is here. So this entire answer simply boils down to this, A intersection B. Or rather, let's do it in white. So here's another example. B union not C. So B is this, and not C is everything that's not green, which is this. And if we're finding the union of all of that, then we've got to put this blue onto this diagram. So we're leaving out C. Okay. And right here what I have in blue is B union with not C. So everything that's not in this triangle. So all of this outside stuff. Because this is the C triangle here. Union with everything that's in B, which is this triangle. You can see. So essentially we're left with everything that's in blue. And on the right hand side here, we have A intersection B. So what that is that part. And what we want is A intersection B, but the complement of it. So in other words, not everything but what we currently have in green. So in other words, everything in blue. Now we need to find the intersection of these two sets. So basically we're looking for what's in common. What's in this set and what's in this set. So we notice that in this set over here, we have, that's also in this set, we have this outside area. This part. We also have this area. And we have this area here. and that's all that's in common. So we can go and fill that in the diagram. Alright. So here we go, another example. 2 components. So let's tackle this component first. A union B union C. So everything that's in A, or B, or C. So everything that's blue. From this side, we have 2 subcomponents, that and that. Now this one here is A intersection B, which is that. And now we've got to say what's in this component or in this component. So we're going to shade both of them in. So now we've already done this part, so we'll do this part, B intersection C. And B intersection C is this. Alright, but now we look, and this whole thing has a complement up top here. So it's everything but this green area. So in other words, it's all of this. Now, we've drawn this part over here, and we've drawn this part over here, and now we ask for the intersection of these two. So we're looking for what's in common. And you'll notice that this is also in this diagram over here, as well as this area. So we'll go ahead, and actually a nice way to think about it is if I were to color code it. So let's make this color here, let's make it a pink, and I'll transpose this diagram. Alright. And we're looking for what's both blue and pink. And we notice that it's everything but this outside region and this region, because this outside region is only pink, and this region here is only blue, as well as this region. So essentially, we're only including this and this. So to draw it more neatly, we have that. So here's a bonus question, a true or false, and we're trying to identify whether this side is equal to this side. So let's first look at this side and see what we can figure out. So if we were to draw 3 triangles again, sorry, not triangles, circles, A, B, and C, this part here is everything that's not in C. So that's all of this, including the sample space that's not C. Intersection with everything that's in A. So we take everything that's not this, as well as, no, so not as well as, but rather that's also everything in here. So what we're saying is, we're choosing this and what overlaps with the green. So that's going to leave us simply with this. And now we'll look at this here. 3 circles for this part. So everything that's not in C, so we'll say C, B, A, everything that's not in C, which is all of this, and everything that's in B, which is this. So we're taking what's in common from this and all of this, which will leave us only with this. Now we're looking for the union of these two, which means I would put that diagram on top and keep everything. So I'll be left with that. To get rid of that space, because I'm going to use it now to depict the right-hand side. So I've depicted the left-hand side to be this. Now I'm going to depict the right-hand side and see whether they're the same. If they're the same, then I conclude that it's true and these two are equal. Otherwise, they'll be false. So let's look at this in its components. So we have A intersection B as this innermost subcomponent. So A intersection B we know to be just this. And now C union with this is everything that's in C or everything that's in A intersection B. But now we're looking for the complement. So we're not looking for what's in green here. We're looking for what's in blue. So we can rub out this green and say we're simply looking for what's in blue. And now we need to ask ourselves a critical question. Is this the same as this? Well, no, it's not, because in this diagram, we've included this little area here, whereas we haven't in this one, as well as the fact that in this diagram, we don't have the rest of the sample space that's not included in any of these three sets, whereas in this diagram, we have included that. So we say, no,